So we have about, I would say, 5 minutes or so for some general discussion. So really want to throw this open to the floor for conversation now. You can either put questions into the chat, questions, comments, and I can read them, or raise your hand and I'll call on you, and you can unmute and ask the questions directly. So anyone like to kick this off to begin? Nevada, I think you're still sharing your screen.
Oh,
I don't see it, Jack. I just see you.
yeah.
Oh, okay. All right. I'm seeing something different here. But yeah, who wants to start off? So, you know, what we have going forward here is, we've been talking about all this morning, is really a set of guideposts or landmarks or roadmap to begin this systematic process of radio astronomy on the moon, starting off with just, you know, some very simple experiments, going to things that are much more complex, like what Alex and Nevada talked about, and others for the far side array. We've had some good discussions, by the way, with folks in the ESA countries about collaborations between Farside and also some discussions that are taking place in Europe. I'd love to see more discussion about the potential between U.S. and European collaborations, if anybody wants to add a comment. Don't see anybody. Everybody's being quiet today on this. So here we have a question for the lunar polar crater gravity sensor. So Mark, why don't you go ahead and unmute? Mark Henley.
Can you guys hear me all right?
Yes.
Okay, great. It's a question about the gravity gradient, or I'm sorry, the gravity gradiometer in the polar crater, and it was the power supply. I like power beaming, laser power beaming as an option, but there's a current NASA innovative advanced concept study of reflected sunlight, and there have been a few other ideas to reflect sunlight rather than converting power to laser, beaming it, and then converting it again into electricity. So has that been considered? Is that one of the options that you're thinking of, or is that a concept, or is it too far? This was over short distances, like maybe a kilometer, but not long distance.
So no, actually, that's the first time I have heard of this idea, but I like it. Yeah, good point. You can avoid some of the conversion back and forth between light and energy and other energies. Yes, good point to think about. Yes, it might work well for us because our power requirements are quite low. So we believe that we can stay, let's say, under 200 watts for the entire setup. Mm-hmm. So good idea.
Any other questions? We're running out of time in this discussion session. So anyone like to ask a last question or make a comment before we wrap this up for today?
Actually, Chuck, I had a general question. I think this is alluding back to someone else asking, with all the more missions going from Europe and US, that the lunar far side might not be as radio quiet with the different missions. Is it possible, or are they thinking on the lines of, can we timeshare between the different missions, or would that reduce our sensitivity when we're going for we need more data.
Yeah, I think the problem is, Nevada, that if I'm understanding you correct, is that the various missions and so forth that are ongoing is just, if there's no protection for them, just their power supplies, as you know, and their electronics are just going to be radiating all the time, even if you're not taking data directly. They just tend to have, they're charging their batteries and so forth. So having a more proactive approach to this in terms of some shielding would be a good way to go. But there are discussions that's underway. NASA is aware of this. ESA is aware of this issue. There's a UN committee and international radio science committees are now starting to take this seriously, because we're beginning to see this rise up. We've got the Astrophysics Decadal Survey, which is going to be revealing its results probably in September. And I think those results, if, as we expect, they have something to say about low frequency radio astronomy, this is going to raise the profile even further.
Thank you, Jack. Yeah.
Thanks, Nevada. Anybody else? Last question before we wrap up for today. So Ethan Ayeri asked about the timeline for Farside. Let me just say that we've baselined this for later in the decade, the time frame about 2028 or so. This was the engineering design study was for a probe class mission, which is about $1 billion mission. One landing would provide all of the rovers and the equipment, the correlators and so forth to operate. All right, I think we're going to stop there for today. I want to thank again all of the speakers. Great job, everybody, particularly our students and their presentations. Excellent. And once again, encourage everybody to go to the astrophysics poster session. Thank you all. See you soon.